Hello, welcome back. Today we're going to continue our discussion on antiderivatives, more importantly the trigonometric functions. Yesterday we learned that to find the antiderivative of a function, we just need to find the inverse of the derivative. And we saw that yesterday with our power rule here. And in the power rule, we said if when taking the derivative, we would drop the power and subtract 1. In the antiderivative, or the integration rule, which we're going to call it as well, we would add 1 to the power and divide by the new power. And if you notice, the exact opposite or the inverse of what we did for the derivative. The only thing we have to do here is we have to add this plus c, which we call the constant of integration. The plus c, hopefully you remember from yesterday's video, says if I have a function, for example, x cubed plus 3, or let's say I have another function, x cubed plus 4. Notice if we take both of their derivatives, they're the same. We get 3x squared for both of them. This is the constant. We don't initially know what the original constant was for the function, because remember, for the antiderivative, we are trying to find the original function itself. Given the derivative, find the function. So because we don't know what the original plus c was, because it becomes 0 when you take the derivative, we just add this plus c. And that means something for us. It tells us that this is not unique. So is this going to be unique? And of course the answer is going to be no. Now, we can apply the same inverse rules for our trig functions. For example, we know that the derivative of sine is cosine of x. Well then, what would be the antiderivative of cosine of x? Well, in other words, we're asking what function has a derivative of cosine of x? Well, the answer, of course, is sine of x. So this is just going to be sine of x. Now remember, it has an initial constant there, but we don't know what it is, so we're just going to call that plus c1. So the antiderivative of cosine is sine of x plus our constant of integration. And likewise, we can continue on. We know that the derivative of cosine is negative sine. So we say, well, what's the derivative of positive sine? Now be careful, notice we want positive sine, not negative sine, so we want to do the opposite. We know we're going to get cosine of x, but it's going to be negative. We just take that negative and put it on here. So the antiderivative of sine of x is negative cosine of x plus c1. The derivative of tangent of x is secant squared. So likewise, the antiderivative of secant squared is going to be tangent of x plus c1. Don't forget the constant of integration. Now remember, these have special names to them. Because of that plus c, we call these an indefinite integral. And are these unique? And the answer is no. So therefore we say these are not, again, unique. So none of these with a plus c would be considered unique. So let's keep going. The derivative of cotangent is negative cosecant squared. So if I want to go find the antiderivative of cosecant squared, be careful. We're going to take the negative and put it over here. This becomes negative cotangent of x plus c1. And again, this is not unique because of that plus c. That plus c means it can be anything. The derivative of secant is secant tangent, so the antiderivative of secant tangent is going to be secant of x. In other words, we're saying, I know that the derivative of secant is secant tangent. We just want to go the opposite way. What function's derivative is secant tangent? And that's going to be secant of x. Now, give me a second. I'll show you kind of a trick how I can remember these. I don't remember all these antiderivative rules. I'll show what I do. What function's the derivative of cosecant is negative cosecant cotangent. So same thing. I want to find what function, the derivative of what function is this. What function has a derivative of cosecant cotangent? And it's going to become negative cosecant cotangent of x plus c1. Whoops, I did mess up there, and I want to fix that. because I don't want you to make this mistake. This is going to be negative cosecant of x, just cosecant of x, plus c1, plus our constant of integration. Now, how do I remember these? Well, one hint is, remember, cos always go negative, so cos go negative. Cosecant, cotangent, negative. Cosecant, negative. And sine, I guess, is the other one. Co, there you go. Co is negative. See, co is negative. Cosine. But the other one I remember, I don't remember all these rules. I just remember all the derivatives. So if I know all these derivatives, I know I got the answer. I can just go backwards, work it backwards. Now, here's the hint. If we're not given this, not given a known derivative, we can't solve yet. Okay? There's a lot more tricks to these later on that we'll talk about. So if it's not one of these, take a look here. If it's not one of our rules here, we won't be able to solve these just yet. So let's take a look at some examples here and have some fun. All right. We want to evaluate the following indefinite integrals. So for the first one, this is negative 3 sine of x. Now, if you want to, you can rewrite this. You can factor out the negative 3, and that's going to become the antiderivative of sine of x dx. We're going to call it the integral or the antiderivative. Now notice we're looking for indefinite integrals. So what this is telling us is that this is not going to be unique. So therefore we're going to need the plus c1. We're going to need that plus c. So I'm ready to solve this now. The negative 3 is just a constant. We leave it here. And I ask myself, what function's derivative is sine of x? So if I go up here in my chart, what function's derivative is sine of x? Well, I guess I go over here. The antiderivative of sine of x is negative cosine of x. So this is just going to become a negative cosine of x plus your constant of integration. Now, we don't typically like to leave it like this, two negatives. They do make a positive, so we can write it. I promise you we're not going to do this much work in the future. There we go. All right, let's take a look at number 2. For example, number 2, right here, this one, this is just our power rule. So what's the antiderivative of 3x cubed? Well, my rule says I'm going to add 1. This becomes 3x to the 4th over 4 minus, and now I got to think, what function's derivative is cosine of x? Well, that's just sine of x. And I can verify that up here. If I go up for antiderivative of cosine, it's just sine of x plus your constant. Now notice I'm doing a little bit different. Yes, I didn't split all these up. Plus c1, don't forget the constant. And you can leave it like this, or you can get rid of the parentheses. This is fine. That's cool to have. So notice here I didn't split my integral up like we did yesterday. You don't have to all the time. Over here, what function's derivative is sine? Well, again, that is negative cosine. We saw that over here. So this is negative cosine theta. If you don't like theta, change them to x's. Plus, this again is our power rule, theta squared over 2 plus c1. Remember, these are called indefinite integrals because we don't originally know what that c was. This right here is unknown to us. We don't know what it was originally. So this is my function, this is my derivative. I can easily check my answer by taking the derivative. The derivative of negative cosine is sine of theta. If I take the derivative here, drop my power, I just get theta, plus, and c1 becomes 0. And notice we get the exact same answer as before. So we can actually verify that this does work. All right, let's try number 4. Oh no, our function is broken. No, it's not. I'm just being silly here, of course. If we take a look at a problem like number 4, after number 4 here we'll take a break and go to the next video. If we take a look at number 4, notice it's not on our list. It's not one of our known answers by looking at it. So right now we say, oh, we can't solve this yet. But we took pre-cal last year, so we know some trig rules. One, I can distribute, and that's what I'm going to do here. when I distribute, I get cosecant x cotangent of x minus cosecant squared of x dx. And these I can actually solve. I'm going to do them independently from each other. So remember, the problem is there is no product and there's no quotient rule here. So because there's no product or quotient, especially for trig, we got to get kind of trigalicious with them. We got to work on our trig values here. So let's go ahead and try this one now. The antiderivative cosecant cotangent, if I go up to my list here, there it is, cosecant cotangent is negative cosecant of x. So this is just negative cosecant of x minus, what's the antiderivative of cosecant squared? So if I go up here, it's negative cotangent. So this becomes minus a negative cotangent of x plus c1. Now if you notice, even though I'm taking two antiderivatives and both of these have a constant, we talked yesterday we can just combine it to make it one constant instead, and it makes it a little bit easier for us and less busy for us. I'm going to simplify this a little bit. Negative cosecant of x plus the cotangent of x plus your constant of integration. And there's our answer. All right, go on to the next video and we will take a look at some more examples. I'll see you then.